Today we study about combinational circuit minimization. To do this one, you can use some switching algebra to reduce number of variable or number of term. That means when you reduce number of term and number of variable in the function expression, that means you use less component to implement the circuit. For example, if your function is a and b and c and y plus a and b and c and y prime, if you use combining theorem, you can reduce this expression to only a and b and c, right? Okay, based on this theorem, you can reduce function to minimize size of the circuit. But it's not convenient if you use just only switching algebra. Okay, today we will introduce you one technique that you can reduce by using something like graphical method. Okay, at first, the objective that you can, or the result of minimization with this technique, you get minimal sum. Okay, minimal sum or minimal sum of product. Okay. Minimal sum of product. That means your result will be the form of sum of product term. Okay, sum of many term, and each term is in product form. So the minimal sum, okay, you will have smallest number of term, and each term we have smallest number of variable. So that's called minimal sum. Okay. Similarly, if you write in product of sum, if your product of sum has minimal number of sum term and minimal number of variable in each sum term, so it's called minimal product. Okay, this method actually is based on okay, let's see this example. Okay, this example, okay, take a look. This function have three input variable x, y, and z, and one output f. At first, let's focus only on logic 1 output. Now, last time we already know how to write canonical sum, right? To represent the function. Okay, just focus on logic 1 output by writing minterm. Okay, corresponding minterm and sum out of minterm together. For example, this one, this f will be 1 when input x, y, z is 0, 0, 1. That means the minterm is x prime and y prime and z, right? And this term 0, 1, 0 plus x prime and y and z prime. How about this term? This term also gives logic 1 output. The minterm of this is 1, 0, 1. Then it is x and y prime and z. How about this? This one is 1, 1, 1. So the minterm is x and y and z, right? That finished. So you can get the function completely. by writing in sum of minterm or canonical sum. And now, if you want to minimize the function, you may use switching algebra theorem. For example, combining theorem. For example, this term, y prime z, y prime the same, right? But x prime, x different term, right? So you can reduce these two terms to y prime z. Okay. So if you look on this one, x prime, y prime z, okay, is this one. And x and y prime and z is this one, right? The input of 0, 0, 1 and 1, 0, 1. Okay. Based on these two terms, okay, let's interpret something. The output will be 1 when the value of x, y, z is 0, 0, 1. For this one, 1, 0, 1. So, if you look only these two terms, note the function will be 1, okay, when what? X is 0, y is 0, z is 1. Or x is 1, y is 0, z is 1. Okay, so based on these two terms, the output will be 1 when y is 0, z is 1. It's not depend on the value of x, right? X can be 0 or 1, right? It not affect the result. Okay. Just only y, z equal to 0, 1. So you can write these two terms. 2 y prime z. Okay, this is the meaning. Namely, this term will be 1 when y equal to 0, z equal to 1. Okay, not depend on the value of x. Okay, but x. Okay, but when you apply the input 0, 1 to yz, you must apply input x also. But because of digital variable, right? Okay, value of x can be 0 or 1, right? That means there are two cases, okay, to make the function to be 1 for y prime c term, namely 0, 0, 1 and 1, 0, 1. Okay, that means actually you need not to write this expression. Actually, you can observe from these two tables. Just find out the input that make output to be 1 and the input different only 1 bit. Namely, in this case, 0, 1, 0, 1, the same, right? But for x, for this x, this term x is 0, this term x is 1. That means it's not dependent on depend on x. Okay, it depends on value of y and z. Y and z must be 0, 1. That will give logic 1 output. And actually, this term also, no, this one, this term, this term, x, z, right? X, z, right? Same part. But this one, y prime, y. That means you can combine these two terms together, and the result is x and z. Okay, by combining theorem. And actually, you can look directly from the two tables. Namely, x, z is 1, 1, 1, 1, right? For this one. y is 0, y is 1, different only 1 bit. So you just find out the input, okay, that different only 1 bit, but give the same logic 1 output. So you can write product term, okay, to represent, okay, this input and this input that make logic 1 output. Okay. Anyway, if you look on the two table, it's not easy, right, to find out the input that make logic 1 output but different only 1 bit. So to make it more comfortable, to find 1 bit different input that make logic 1 output, okay, we will write down the new table that keep the same information of input and output, something like this. Okay. Let me write this one without this one. For this one, there are 1, 2, 3, 4, 5, 6, 7, 8, right? 8 case of the input. That means there are 8 output, okay, for each combination. So we write down something like this table, and input value, for example, maybe I write x, y at here and z at here. The input value of this cell is 0, is for example 0, 0, 0, right? 0, 0, 0, and output is 0. Okay, let I write all possible value at here. 1, 1, 1, 0, 1. Okay, for this example, okay, this cell, the corresponding input is 0, 0, 0, and output is 0. Okay. And for the cell, this one, for the cell, input of this cell is 0, 0, 1. Okay, 0, 0, 1, output is 1. So you write it out 1 at here. Okay, you just write output value in the cell. Okay, how about this one? For this cell, the input is 0, 1, 0. 0, 1, 0. Output is 1. Okay, and you can do this. Okay, and what else? X, Y, Z, 0, 1, 1, 0, 1, 1, 0, and what else? 1, 1, 0, 1, 1, 0 is 0. How about this cell? 1, 0, 0, 1, 0, 0 is 0. How about this cell? 1, 0, 1, 1, 0, 1 is 1. And this one, 1, 1, 1, this cell, right? 1, 1, 1 is 1. Okay, you just write new format from two table. Okay, this chart or this table, it's called kernel map or key map. Note, okay, one thing that very important that you should know about the key map. At first, the thing that you write in the table is output value. Okay, the output value for the input. Okay, the corresponding input. Okay, we write outside the table. Okay, and note the input value for this cell and this cell, the adjacent cell, For example, this cell input is 111. This cell input is 101. The input value of adjacent cell will different only one bit. Why? That because we write down the value of input in gray code sequence, which different only one bit. So that means you can find out, or you can group the input that make logic 1 output with different only one bit easily. For example, if you focus on logic 1 output like this, for this term input x, y, z is 1, 1, 1, right? So the product term of this is x and y and z. How about this one? The input of this logic 1 output is 1, 0, 1, right? So you can write this one as x and y prime and z. When you combine these two terms together, the result will be what? X and z, right? Anyway, if you consider the input value of this cell and this cell, the input value is 1, 1, 1 and 1, 0, 1, right? That mean if you consider only these two cells, the result is not depend on the value of y, right? Y can be 1 and 0, not affect the result. Just to keep the value of x and z is 1, 1. You will get the result 1, 1 for the function. So that means if you use this schema, you can consider these two cells directly at the same time. You need not to select or find a product term of this cell and this cell first and combine it later. You can consider these two cells together and you just consider the input value. For example, this cell x is 1, this cell x is 1. That means the resultant product term will have the value of x, right? X must be 1. But for y, this cell y is 1, this cell y is 0. That means this not depend on the value of y. So there is no y in the product term. This cell z is 1, this cell z is 1. So it is based on the value of z with 1. That means you can write product term of these two cells together in x and z. How about this one? For this one, there is no adjacent cell that give logic 1 outputs. That means you can write it just like x prime and y and z prime, because this cell the input is 0, 1, 0. So x prime and y and z, like midterm that you derive from two tables. The same thing. And how about this one? This term, this logic 1 output, its input is 0, 0, 1, right? So you can write that x prime and y and z. Anyway, this cell input is 0, 0, 1, right? This cell is 1, 0, 1. Oh, it's one bit different right? One bit difference. So you can combine them together. If you consider this product term, is x prime y prime z. It is x y prime z. Okay, y prime z is the same. So you can combine them together and the result is y prime z. Or from Kmap, actually you can group this cell and this cell together directly, because this cell and this cell different only one bit. Okay, you can group, okay, them together. So this cell x is 0, this cell x is 1, different, right? So variable x disappear in the final product term. This cell y is 0, this cell y is 0, so y prime. Okay, this cell z is 1, this cell z is 1. So after that, when you select all logic 1 output, you just add all of them together to complete the function. Okay, because your function want the logic 1 output for this input, right? For case. Okay, that's all. So from this one, maybe something like this. Okay, by the result. Again, okay, let's consider this term. This term is from this cell. Okay, the input of this cell is x, y, z is 0, 1, 0. It's x prime and y prime and z. That means this term will be 1 when what? When x prime is 1, namely x is 0. When y is 1, right? And when z prime is 1, so z is 0. So this case will be 1, just only one case. Okay, it's min term. And this term, y prime z. Y prime z is from this one. This and this. Okay. This cell is 101. 101. And this cell is 001. 001. Okay. Sorry. 0. Okay. 001. Okay. That means we want this case and this case. There are two cases for this term. This product term give logic 1 output at here and at here. And for x and z, we want when x is 1, z is 1, right? So x is 1 at here, z is 1 at here, x and z is 1, 1 at here. So there are two cases for this product term. After that, when you sum, okay, all these product term together, the result will give the function that you want. Namely, when you apply the input, for example, 0, 0, okay, this term is 0, this term is 0, this term is 0. When you all together, the result is 0. But if the input give some product term to be 1, when you all or you add to another term, the result will be 1. Okay. And please note for this input, this input in Kmap is this one, right? 101. This one. This one is grouped by this term and this term. So when you apply this input, this term will be 1 and this term also will be 1. Anyway, when you sum together, okay, you will give the same result. Output is 1. That means you can select, okay, logic 1 output cell more than one time. Okay, if you can, if you select it and it make a bigger group, that means you can reduce number of variable of the product term. This point is very important. So now you can get the function with minimal sum from, and then you just write circuit diagram, follow this expression. Okay. If you compare with the method that you studied last time about canonical sum, for canonical sum you just consider each logic 1 output, right? And then you write down minterm. Okay, from the corresponding input. Namely is x prime, y prime, z plus x prime, y and z prime plus x and y prime and z plus x and y and z. Okay, or you select form K-map. If you select only one cell, and this cell, right? The product term of only one cell is min term. Namely, for example, 0, 1, 0, right? For this cell, then it's x prime, y, and z prime. For this cell, 1, 1, 1, so x and y and z. For this cell, 1, 0, 1, x and y prime and z. For this cell, 0, 0, 1, x prime, y prime, and z. Okay, when you sum all this together, you get canonical sum. Okay, same function, but if you write in canonical form, maybe the function, okay, is quite big. That means if you implement the circuit follow this expression, you will use so many logic gates. But if you minimize, namely if you select some product term by grouping 2 or more cells together, you can reduce size of the circuit. This is the concept. And don't forget that you must select all cells that obtain logic 1 output. You must select all, and you must not select logic 0 output, because your result, okay, each product term will give logic 1 output, right? For the corresponding input that make this term to be 1. Okay, and how about this one? For this example, for this function, actually you can again complete the function by find minterm for each logic 1 output. But when you implement the circuit, it uses so many logic gates. So now let consider how to minimize or reduce number of logic gates when you implement the circuit. It's very easy. Okay, let's consider this one first. This term, the corresponding input is 1, 1, 0, right? So if you select only this one, your product term or min term is x and y and z prime, right? How about this one? This one is x and y prime and z prime, right? Because the input is 1 0 0. Okay, because it's different, only one bit. Y prime and this one is y. X z prime the same, so you can combine these two terms together. So actually you can consider these two cells, okay, at the same time. This cell x is 1, this cell x is 1, so x and y1 y0, okay, different, so y disappear in the product term. This cell z is 0, this cell z is 0, so z prime. Okay, so you can combine them together. And this was still not finished because you must select all of logic 1, right? Output. Okay, so and if I want to select this one, actually you can select this one also, right? At the same time, because you can select logic 1 cell more than one time. It can reduce, okay, number of variable. So you should select it. If you select these two cells together, that means the product term of these two cells is 1, x is 1, right? Y is 0, x and y prime. This cell z is 0, this cell z is 1, so z disappear from this term. And how about this one and this one? This one and this one, okay, you can group them together. The product term of these two cells is x, y, 0, 0, right? Then x prime and y prime, okay? Z disappear because this cell z is 0, this cell z is 1. Oh, note x prime x, okay? The most left and most right actually is one bit different, okay? Namely, the value of x is 0 at here and 1 at here. So you can combine them together and the result is y prime. That means actually you can select these four cells together and you can consider product term, okay, at the same time. Actually, find out, okay, the common value. Namely, these four cells have the same value of y is 0, okay, but value of x and z are different, so the different value and the value will be disappear in the product term. And now you select all of logic 1 output cell, so your function will be y equal to what? X and z, right? Plus what? Y prime. Finish. Okay, right? This one. If you look this schema, okay, and let's consider the meaning of each term. And your function is x and z prime plus y. That means this term will be 1 when x is 1, z is 0, right? Then there are two cases that x is 1, z is 0. Okay. Not depend on y. Y can be 0 or 1. Okay, the result is the same. And how about this term? Y prime. Y prime will be 1 when y is 0. Namely, there are four cases, right? Y is 0. With 1, 1. When you add these two terms together, you obtain the final result that you want. Okay. Okay, and again, for this input, this term is 1 and this term is 1 also, because this cell, right, this input 1 0 0 1 0 0, okay, is selected by this group and this group. Okay, you can select more than one if it help you to reduce number of the variable for each product term. Note, if you select only one cell, it's min term, right? The product term is min term. That means you obtain all input variable. But if you select two cells, okay, your product term will reduce number of variable from 3 to 2 term. And if you select 4 cell, you will reduce one more variable, namely you will left only one term. Okay, and note, I for this K-map I write down just only logic 1 output, because I focus only logic 1 output. So from this K-map, I don't write 0 in this cell and this cell itself. That mean this cell output is 0, this cell is 0, is 0. So you can write or not write. It's okay, because I will focus only one output. So then it need not to write 0, 0, 0 at here. So you should understand that the empty cell means the output is 0 for this case. Okay, let's just summarize. And let's go this example. Actually, this example is the same problem from the previous lecture. Maybe this one. This one, right? You want your output to be 1 when input value is 1, 2, 3, 5, 7, 11, and 13. So you just find min term, for each input, and then you write down the circuit diagram. There's so many logic gates. But if you use K-map, to find the function, something like this. From this one, you can write and focus or concentrate just logic 1 output at here and here and here. So I find the product term to complete the function. At first, someone maybe select this one. This logic 1 is okay. It's okay, but not good enough. Now I want to find the minimal sum. That means each product term must have a smaller size or smaller number of input variable. That means if I can select bigger or can grow, not 1 but 2, you will reduce number of input variable, right? So in case I not select 1, but I select these 2 cells together, so I can reduce number of variable. Namely, the variable n3 will be disappear, right? Because this cell n is 0, this cell n is 1. And the product term of these 2 cells is n2 is 1, right? So it's n2. And the cell n1, n0 is 0, 1. So it's n1 and n0 prime. But it's still not finished. You must, don't forget, you must select all of logic 1 output to complete the function. What about this one? Select these 2 cells. No, it's not good enough. You can select this 4 cells. And when you select this 4 cells, you can reduce variable into, right? Because n2 is 0 at here, 1 at here. So n2 disappear, n3 is 0, 0. So n3 is n3 prime. And if you consider value n1, n0 for this 4 cell, n1, 0, 1, 0, n1. So n1 disappear, n1 is 1. So n0 is at here. And how about this logic 1 output? You can select this one. Yes, but it's not good enough. You should select these 2 cells together. So the result of product term is what? N3 disappear, right? Because N3 0 is here, 1 is here. And N2 is 0, right? Then N2 prime, N1, N0 is 1, 1. And N1, N0. And the last one, this one, you can group these 2 cells together. So these 2 cells, N3, N2 is 0, 0. So then it's N3 prime, N2 prime, and this cell N1 is 1, and N1. N0, 1 at here, 0 at here, so it's disappear. After that, you just sum of these 4 product terms together. You will obtain the function in minimal sum from. Okay. After that, you can implement the circuit follow this expression. After that, you may apply, for example, apply to the input, and then you just test the output that you get as you want or not. For example, when I apply 0, 0, 0, 0, output is 0. When I apply 0, 0, 0, 1, output is 1. Okay. There are 2 levels, right? Low and high. Okay, low is 0, high is 1. Okay, this is just it's called timing gap. Timing gap. In this case, I just apply all possible value of input, namely from 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0 until 1, 1, 1, 1. Okay. Okay. And before continue, let do some practice from this example. Now, one more skill that you should have is you must be able to mapping, okay, the product term to K-map. Namely, you must be able to consider this product term will be 1 when input value is what? 1, 1, 0, 1, right? A must be 1, B must be 1, Z must be 0, C must be 0, and D must be 1. Which cell in the K-map that have the input A, B, C, D is 1, 1, 0, 1. A, B is 1, 1, C, D is 0, 1. This cell, right? Okay, can write 1 at here for this product term. Okay, note, if your system, okay, have 4 input variable, if the product term have all 4 input variables in K-map, will cover only 1 cell. And how about this? Okay, if I remove 1 variable and obtain the new product term, this product term have 3 input variable. Okay, this term will be 1 when A, B, C is 1, 1, 0, right? Then you just consider when A, B, C is 1, 1, so A, B is 1, 1, Z is 0, Z is 0 at here or at here, right? That means it's cover these two cells that can make this product term to be 1. Okay? So the size of group in K-map will increase, right, from 1 to 2 cells. And how about this? When I remove one variable and then it becomes BC prime, how about the result? This term will be 1 when B is 1, Z is 0, right? B is 1 at here and at here, 0 at here and at here. That means it covers this 4 cell. So the size of group, okay, is bigger. From 1 to 2, from 2 to 4. And how about this? For B, this term will be 1 when what? When B is 1, right? So with cell B is 1, this, and this, right? This 8 cell, B is 1. So the size of group become bigger from 4 to 8. Finally, if the function is 1, what happens? That means the function always 1, right? Not depend on the value A, B, C, D. That means every input you give logic 1 output, right? So when you group in K-map, you will just group all cells in this K-map that give logic 1 output. Okay, so from this, you can take a note that mean if you want to select some cell in the K-map to produce product term, you must select one cell or 2 cell or 4 or 8, right? Something like this. You cannot select 3 cell. You cannot select 5 cell, and you cannot 4 cell in this pattern. Okay, you can select 1, 2, 4, 8, and so on in maybe rectangular pattern. Okay, square or rectangular. This one or this one, actually this one also possible, right? Must keep this pattern. Okay, and how about this? This is very easy, right? You just select these 2 cells, and these 2 cells C0 1, so C disappear, right? D is 1, so D, right? A, B is 0, 1, so it's A prime and B and D. Okay, very easy. How about this one? You can select these 4 cells together, and the product term is what? A, B, 0, 0, right? So it's A prime, B prime. How about this one? This one, okay, 4 cell, A is 1, 1, right? B is 1, 0, so B disappear. C is 1, 1, so A and C. D 1, 0, so D is disappear. Then your function is what? A prime, B prime, plus A and C. It's your function in minimal sum form. Okay. And how about this? You can say A cell together, right? And this A cell, A is 0, so it's A prime. How about this one? This 8 cell, this one, right? So it's D. How about this? You can select this 8 cell together, because this row and this row is different one bit of A, right? And B is 0, 0, so this A cell is B prime. Okay, that's all. How about this? For this one, you want to find function in minimal sum. you can select what? This cell? No, not so good. These two cells? No, you can select these four cells together. And the product term of these four cells is what? Is A0 is here, A1 is here, so A disappear. B0, B0, right? So B prime, C0, 0, and C prime, D0, this one, this disappear. And how about this one? Okay, you can group this and this, right? And the product term is what? AB is 1, 1. So A and B and what? D is 0, right? C is 0, C1, C disappear, D is 0, 0. Okay, so D prime is here. And still not finished. You must select all of logic 1, right? For this one, you should select these two cells. So A, B is 0, 0, right? A prime and B prime and D is 0, 0 and D prime. So C disappear. That means your function is what? Sum of these, okay, sum of these three product terms, namely B prime, C prime plus A and B and D prime plus A prime and B prime and D prime. Finish. Okay, very easy. Okay. To write down K-map, okay, don't forget that the one thing that very important is the sequence, okay, or the order of input value must write in gray code sequence. Namely, for 2 bit is 0, 0, 0, 1, 1, 1, then 1, 0. 0, 0, 0, 1, 1, 1, and then 1, 0. Okay, this is four input variable. And how about this one? If your system have got 5 input variable, you can write down K-map in this pattern. Namely, this cell, for example, this cell input A, B, C, D is 0, 0, 0, 1, and E is 0. This cell A, B, C, D is 0, 0, 0, 1, and E is 1. Okay, that means if your output is 1 in here and 1 is here, you can group these two cells together. Okay, E different, so E disappear, and your product term then is A prime, B prime, C prime, and D. Okay, and for sixth, okay, input variable. In this case, A, B, C, D, and then E, F. Okay, these 16 cell, okay, the value of EF is 0, 0. This 16 cell value of EF is 0, 1. This 16 cell value of input is 1, 0, and this is 1, 1. Okay, note this group and this group is one bit different of E. This group one bit different of F. Okay, this group and this group one bit different of E. Okay, you can do arrangement like this. Okay, let's back to the slide. Maybe this one. Okay, some technical term that you should know about K-map. The first one, minimal sum. Okay, the result function that you obtain from K-map usually is minimal sum. Namely, is right in sum of product term. Okay, sum of product term. Okay, each term is product term. Okay, for minimal sum, you have the smallest number of product term, and each product term we have got smallest number of variable. And for imply, here product term P imply function f. Okay, for example, this one. For example, function f product term P, maybe this one, x and z prime. Okay, input that make this product term to be 1 will make function to be 1 also. Okay, so we say that this product term imply f. Okay, that's all. Okay, this is the meaning of imply. And prime implicant pi. Okay, prime implicant is a normal product term P that imply f, such that if any variable is removed from P, then the resultant product term does not imply f. Okay, for example, this one. Okay, the previous example. Okay, this one. Okay, let's see this example. If I start with this term, the term of this cell is what? 1, 0, 0, right? That is x and y and with x, y, and z, x and y prime and z prime, right? And the input that make this term to be 1 is 1, 0, 0, right? 1, 0, 0, okay? And this 1, 0, 0 also make function f to be 1. That means this product term imply f. And then if I remove one variable, maybe I remove z. Now your product term become x and y prime. Namely, the input make this term to be 1. X must be 1, y must be 0. Okay, 1, 0. All this 1, 1, 0. Okay, this product term make function to be 1 also. So this product term imply f. That mean x and y and z prime is not prime implicant because you can remove it. Okay, and if you see in the K-map, x, y prime is this cell and this cell in K-map. Okay, if I remove more one variable, for example, if I remove x, okay, so this product term then become y prime, right? This term will be 1 when y is 0. Okay, when y is 0. And the input that y 0, namely 0, 0 or 0, 0, 1 or 1, 0, 0 or 1, 0, 1 also make function f to be 1. That means y prime imply f. So the previous product term x and y prime then is not prime implicant because you can remove one variable. Okay, and then can you remove more one variable? No, if you remove this one, you will give the result out of this that cover logic 0 output. So it's not imply f. So that mean y prime is prime implicant because you cannot remove more variable. If you remove it, the new product term will cover logic 0 output. Okay, this is the meaning. So, to obtain the minimal sum, you must use prime EBCAN, right? In KMap, right? You will not select, for example, this cell. Okay, it's better if you select 2 and very better, okay? If you select this 4 cell. Okay, this 4 cell, the product term of this 4 cell is prime EBCAN. Okay, this is the meaning. So, if you want to make the function write in minimal sum, you must use prime EBCAN. Okay, so it is called prime EBCAN theorem. Okay, a minimal sum is always sum of prime EBCAN. Just select sum. But anyway, if you use all prime EBCAN of the function, it's called complete sum. For example, this KMap. This KMap, there are 1, 2, 3, 4, and 5. 5 prime EBCAN like this. Namely, if you select this 4 cell, right? The biggest cell that you can group that cover only logic 1 output, not 0. This product term is this one. This product term is this one. Okay, this product term is prime EBCAN. And this one also. Okay, this one also. Okay, and this one also. Okay, this product term. So there are 5 prime EBCAN. If you make the function by sum all of these product term, you will get complete sum. Anyway, if you want to make the function just minimal sum, you need not to use all of this, right? You just use, okay? You just use only necessary product term. Just cover all of logic 1 output. That's okay. For example, if you select this group, and then this group, that's enough, right? You need not to use this group, right? Because actually this and this, okay, that's enough to cover all logic 1 output. So the minimal group or minimal prime EBCAN that you use, okay, you will produce minimal sum. Okay, so okay, just for example. And to obtain minimal sum, maybe you should know the word of distinguish one cell and essential prime EBCAN. Let's consider this example. This logic 1 is covered just only by this group, namely this prime EBCAN, right? This product term. That means you want to complete the function. That means you must select all logic 1 output, right? So to select this cell, that means you must select this product term also. So this product term then is essential prime EBCAN. Okay, you must select this. Okay, and the cell that cover only this essential prime EBCAN is called distinguished one cell. Okay. So another discrete one cell is this one, right? And this one. That means you must select, okay, this essential primary key, okay, to complete the function. So to find the minimum sum, you must select essential primary key first. Okay. 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 And if he asks you about the discrete one cell, okay, let you answer in the min term or the product term of that discrete one cell. Okay. Okay. And some function may have no any essential prime weekend, and some function uh, maybe have many form of minimal sum. For example, this came up of one function. The prime weekend is this one, this one, this one, this one, this one, and this one, right? Okay. So there is no any discrete one cell. Then there is no essential prime weekend. And to get minimal sum, you may select this, and this, or you may select uh, this, this, and this. So there are two set of minimal sum. Okay, need not only one. Okay, it just summarize. And how about if I want to find minimal product? Okay, for minimal product, the result you want is product of sum, right? Product of sum. That means you should focus logic zero output. Actually, you can do the same. Okay, just write down. Okay, zero in the K-map, and then you select it. For example, this two cell. Okay, this two cell will be zero when what? When x is 0, y is 1, right? Not depend on z. So you can write it as what? X plus y prime, right? Because when x is 0, y is 1. X plus y prime then give 0 output. Okay. And for this cell, okay, its some term is what? 1, 0, 1, right? So you can write as x prime plus y plus z prime. So your function then is sum product of this sum term. That's all. Okay, just example, very easy. So take a note. The input that make this sum term, okay, to be 0 will make function to be 0 also. Because what? Because this term and this term, right? When this term is 0, and any value will be 0. Okay, very easy. Okay, and the next one, don't care some circuit or some function. For example, if you want to show something like it's called serial segment, maybe someone maybe know, and this is the input. Namely, if I apply a 4-bit input, the value is 0, 0, 0, 0. I want to show or display 0. And if I apply 0, 0, 0, 1, I want to show 1. And if I apply 0, 0, 1, so I want to show 2. okay, and so on until 9 is 1001. Okay, show 9 like it. Okay, like this. That means when you use this circuit, you just apply the value 00 to 1001, right? But for 4-bit, the possible value is up to 1111. That means the value of 1010 to 111. Okay, you don't care their output, right? So in this case, it's called don't care. Okay, don't care. Namely, for example, if you want the function to be 1 when input is 1, 2, 3, 5, 7, and 10 to 15 is don't care. That means if you apply the value of the input is 0, output must be 0, right? If your input is 1, output is 1. Okay. If you apply value 2, 2 is in onset, right? So the result then is 1. Okay. Oh, sorry. Onset is this one. Be something sick. And don't care set is this one. Okay. Let I move this. Okay. 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 That mean if you apply the input that not in onset and not in don't care set, the value of the function will be 0. Okay. Okay. Now, if you write the keymap with don't care, what should you do? Okay. For example, for the value of 10 is 1010, right? That means n3, n2 is 10, 10, n1, n0 is 10. So the output for don't care, output can be 0 and also can be 1. Okay, because you don't care it. In the keymap, then you write 0 and 1 or D in the keymap. Anyway, to implement the function, if you get the final equation of the function or final circuit after you implement it, if you apply the input value of 1010, of course the output of the function must be 0 only or must be 1 only. Based on that, your function, okay, give the result is 0 or 1 at here. Okay, now let's consider if I find the function from this keymap. Of course, I must select all of logic 1 output, right? At first, I select this 4 cell and the corresponding product term is what? 1 at here, right? And 0. And 0 at here, and 0 and n3 prime, right? Of course, I must select this logic 1 also. But, okay, to minimize the function, it's not so good if I select only this one cell, right? This 2 cell is okay, but it's not the best. The best one is select this 4 cell. That means now I consider this don't care as logic 1 output. So if I select this 4 cell, your result, the product term of this 4 cell is then what? N301 at here disappear, N200, so N2 prime, and what? N111, okay, and N1, okay, N0 1 is here, 0 is here, disappear. That's all. Then your function is sum of these two terms. And note, this don't care, you don't use it. You don't select it. That means your function, okay, if you apply the input for this cell and this cell and this cell and this cell, you give logic 0 output. Okay, that's all. Very easy. Namely, the cell that you select in Kmap, okay, the function will give logic 1 output. The cell that you not select will give logic 0 output. That's all. So you just select don't care, okay, with some logic 1 output to reduce number of variable in product term. Okay, that's all. Very easy. And if your function have 2 or more output, namely multiple output to the design, actually you can design each output separately. For example, if your circuit have an input X, Y, Z, right? 3 input and 2 output F and G. Okay, you can find equation for each output related with input, this one and then this one. Okay, you can consider separately for each output. Okay, after that you can implement the circuit, okay, follow each one. Anyway, some case you can reduce by use some common term. Namely, for example, function f have x and y term, function g also have got x and y term. That means you can reduce one AND gate. Okay, you can use x and y signal from this AND gate. Okay, so something like this. Okay, and for this one, just some example that have 3 output. Again, okay, you maybe use Kmap for each output to find equation. Okay, for this one, I find I consider logic 1 output and find set of equation for each output, and I also consider logic 0 output, and I just find and consider which term is better, okay, to minimize the circuit. Okay, anyway, basically if you see the problem of many output, of course almost the practical circuit have multiple output, right? So don't worry, you just focus each output, okay, to find output equation for each output. Okay, maybe write one Kmap for each output, and then after to find all output equation for every output, you just consider is there some common term or not. Okay, if yes, you choose it. Okay, that's all for the design. And okay, the end of this chapter.